Alrighty, we're going to get started with the tech track. Again, we have Mr. John Pignotta, and he's going to talk to us about launching your applications the Amazon way. He referred to it earlier, infrastructure as code. So this is a huge topic for keeping your sanity, staying organized, and all kinds of other benefits. So definitely check this out. And again, streaming out in the main area. And if you are going to have questions or anything like that, you want to feel more included, join us in the back room. Thanks.
Cool. Hi again, everyone. So we're going to talk through some more DevOps-y concepts in this talk. I want to take you through a few things around some experiences that Amazon as a business had some number of years ago, 17, 18 years ago, and how what we've done internally to continue iterating on our development process, how those learnings are made manifest in some of the AWS services we offer so our customers can take advantage of some of those learnings. So we're going to start, here's just a quick agenda. We're going to talk about what is DevOps, like when we say DevOps, what are we talking about? We're going to talk about Amazon specifically in DevOps and sort of the journey that's happened internally over the past couple of decades around how Amazon ships software. And we're going to talk about the developer tools that you can leverage in your AWS account to leverage some of those practices. Yes? That's cool. I've actually, this deck has, it's all pretend demos. So there's some demos, it's pretty pretend, but we're going to go through some of our developer tools to give you a sense for how they work and how you might be able to use them. Okay, so software moves faster today, right? So, we went from, in the late 90s, animated GIFs of construction workers to like 4 nines of availability in like a couple of years, right? So today, the expectations of software, the expectations for agility within organizations is very different than it was 20 years ago. This was a survey done by one of our partner companies, a company called Puppet Labs. Puppet, anyone ever hear of Puppet? Okay, cool, awesome. So Puppet's a configuration management system, and I would take these with a little bit of a grain of salt because it's a pretty self-selected audience that took this survey. But people using Puppet to implement DevOps practices talked about some of the benefits they see from adopting these practices. Things like 30 times more frequent deployments, 200 times shorter lead times to get something done, less failures, and most importantly, faster recovery when something fails. So these are tangible benefits that people in our industry are seeing from adopting DevOps practices, like getting software in front of customers more quickly, which is what it's all about, and having fewer failures due to automation, and then when something fails, being able to detect that failure and recover much more quickly. So what is DevOps? When we say DevOps, what are we talking about? So it's really a few things, right? The way we talk about DevOps is it's a set of cultural philosophies and practices that are implemented with a set of tools. So there are many, many, many different ways to implement DevOps within an organization. The general anti-pattern that we're working against is the classical kind of waterfall organization where you have a development team and you have an operations team, and they sit across walls from each other, and one finishes a piece of work and throws it over the wall, and then it's the other team's job to kind of operationalize that work. The idea of DevOps here, it's a cultural philosophy where the whole team is responsible for the development and operation of a product together, from inception of the product or project to delivery and operational deployment of that project. And there are practices that are part of that, right? Things like continuous integration and continuous deployment, and continuous monitoring, things like some of the kind of extreme programming, Kent Beck style practices of project management. And then there are tools that you can use to implement these practices. So, development and operations coming together. Shared responsibility and ownership is really the high order bit here. It's not the operations team responsibility solely that the product works, it's everybody's responsibility. And visibility and communication, so ensuring that people are working together. There's the old Agile manifesto from Snowbird from, I guess, 20 years ago now. And there's a great, one of the lines in that is that we value individuals and interactions over processes and tools. So at the bedrock of the agile software development movement was getting people to work together, getting people to speak with one another, and getting people to, as a collective, share responsibility for the success of a project. That's kind of the high order bit of DevOps, in my opinion. So a couple of other practices that you often hear when we talk about DevOps. So one is this idea of breaking down one large application into many smaller applications, or microservices architecture, or services-oriented architecture. This is not necessarily something that you could obviously be working in a team where it's development and operations working together to ship a single piece of code to production. But often what teams find is that breaking a large problem down into smaller problems that could be owned by a smaller set of people leads to increased velocity, right? So if you think about, and we're going to talk a lot about Amazon in a moment, but if you think about the AWS console, when you open up that AWS console, there's 125 little icons in there. There are literally tens of thousands of little teams that are responsible for those, right? So across Amazon, there are tens of thousands of what we call two-pizza teams. The idea of a two-pizza team is that if a project becomes so large in terms of people power that it takes more than two pizzas to feed that team, well, you probably should break that team down, right? So the observation there is that smaller groups of people with complete ownership and ability to act yield faster results and faster time to market. So part of that is ensuring that these small teams, these many small teams, have the tools and the ability to take what they're doing and get it in front of users without being blocked by process or being blocked by procuring hardware or being blocked by whatever it might be. AWS enables this in a big way, right? The fact that you could spin up a bunch of instances or a bunch of resources really fast and run an experiment and run that experiment on those instances helps you enable your team to innovate faster. And smaller surface areas of responsibility are another component of that. A couple other practices here. So when you're talking about DevOps, you often hear about continuous integration, continuous delivery, and/or continuous deployment. So what are we talking about when we talk about these things? So continuous integration is a development practice. This also goes back to kind of the Kent Beck, extreme programming green book. So if you think about software 20, 25 years ago, a common pattern was you'd have multiple developers on a team, and a developer, he or she may have a project and may work in isolation for months, right? I'm going to work in isolation on this project, and I'm going to complete it, and then I'm going to merge it back into everyone else's work. Well, his or her counterparts are doing the same. So you have X tracks of work, different projects. Maybe I'm working on fulfillment. He's working on the ordering backend. She's working on billing integration. Everyone's going in their own direction, and then at the end of some march forward, they come together and integrate, right? These integration cycles were very painful, right? You would spend a lot of time just figuring out, okay, well, you built a square thing, and I have a round hole here. How do we make this work? And you would spend weeks and weeks and weeks just kind of untangling everyone's changes and getting them fit together with a lot of rework. So that's painful, right? What extreme programming taught us is if something's painful, do it a lot, right? So continuous integration is the idea that instead of waiting months and months or weeks and weeks or even days and days, continually integrate your changes back into a single mainline or master branch. So maybe you have 5 different developers working on 5 different tracks of work. They're continually coming back and ensuring that their changes all work together and all fit together. Okay, so that's continuous integration. Does that make sense? Okay, cool. Continuous delivery is taking that work and on a check-in to master or on an integration, building a shippable artifact based upon that. Maybe that's a Docker container image, right? Or maybe that's a jar file in Java. Or maybe it's just like a zip file, right? Some sort of image that you can, some sort of artifact that you can take and deploy in your environment, whatever that environment might be. So it's not automatically deploying it, but it's basically saying we're going to be in a position to hit a button to deploy at any time, because at every check-in, we're going to have code packaged and ready to go that we could put into production. And continuous deployment is the logical endpoint of that, where not only are you building that artifact, but you're actually shipping it to production after every check-in. So every customer check-in, code gets checked in, it gets put to production after going through a build cycle. And there's usually a pipeline of tasks that are involved with that. So, in the old days, deployment would be lots of manual work. There'd be a release engineer, and his or her job would be to run tests and run maybe manual tests and go through a spreadsheet and go through these scenarios, to run some packaging, and then run some magic incantations to get that code onto production. What an automated delivery pipeline is basically a software manifestation of those manual steps that happen automatically without supervision. Okay. That make sense? Everyone follow? Okay. Anyone doing continuous deployment today? Okay, awesome. That's great. Good deal. So I would say 5 years ago it was pretty uncommon to find people doing continuous deployment. I would say today it's becoming de rigueur, right? I think people are, because software has to move fast, because customers are continually, as in the shareholders letter this year, our founder talked about divinely dissatisfied or divinely discontent, because customers constantly want more changes. Having the ability to get changes to customers as quickly as possible is a competitive advantage. And customers and teams are using continuous deployment to be able to service their markets more quickly. Okay, so DevOps and AWS. So there's a few different components of AWS services that you can use to implement DevOps within your own infrastructure. And there's a few different topic areas we're going to go through. So infrastructure as code, microservices, logging and monitoring. So if you're continually deploying all the time, how do you know that what's being deployed is actually working, right? Do you have observability into your application? And then the actual components that do the continuous integration and continuous delivery. So let's start with infrastructure as code. So AWS CloudFormation is a service that allows you to represent your infrastructure in a template and run that template within AWS to create those resources or manage those resources. So the idea here is, an anti-pattern is that you're going to launch a new application, you go into the AWS Management Console, and you click a bunch of buttons and do a bunch of things to, is that the internet? Are you fixing the internet? That the internet's over there? All right. You do a bunch of things to get your application running, get your instances running. That is not captured anywhere. It's not repeatable, right? Maybe you wrote down what you did, but it's not easily repeatable. So if you decide that you want to build a new staging environment, or you decide you want to deploy your application to another region, you have to kind of reverse engineer the state of your account in order to replay those steps. It's not auditable. You don't know what changes are being made, right? Because it's just someone going in there. You do have CloudTrail logs, so you can kind of figure it out later, but you don't have any kind of before the event code review of what's changing in your environment. And it's completely done in an ad hoc way, right? That's sort of the anti-pattern. What's better is using a tool like CloudFormation to be able to create these declarative templates to say, this is my infrastructure, these are my resources, and these are how they're configured. Check this in along with your code in your source control system as a first-class piece of software. Do the same code review on it, use pull requests if you're using GitHub, and deploy them from a central location. So infrastructure as code helps us in a few ways. It allows us to capture the state of our environment. It allows us to recreate our environment, either in new environments or in new regions. And it gives us some auditability and some code review of the changes that are being made to our environment. When you have a large team of folks that, even when I say large, even half a dozen people all making changes to your AWS account, it becomes hard to coordinate. Infrastructure as code tools really help streamline that process. And then it's an important part of DevOps because it allows you the automation to be able to very quickly create new environments without a bunch of manual work. Make sense? Okay, cool. So other DevOps practices, so monitoring and logging. So once, observability is super important when we're talking about especially continuous deployment. But when you're operating any application, every system has its own kind of heartbeat. It has its own normal operations. So using the monitoring and logging tools available to you will give you more confidence that what you're shipping to production is actually working. Things like CloudWatch, again, one thing I like to do with customers that haven't used CloudWatch before is build a dashboard. So the first thing you should do when you create a new application, deploy a new application to AWS, is create one dashboard that you can look at to get a sense for everything that's going on within that application. The CPU utilization across your web server tier, for example, maybe the I/O characteristics of your database server. One thing I like to add is what's our AWS cost this month, right? How much money are we spending on AWS? Put that on your dashboard and keep an eye on it, right? Because that's part of your environment. If you start seeing that spike up, that's something to look into. So observability is super important. Logging is really important. When the problem occurs in your application, how do you debug it? Logs are there to help you do that. There are lots of partner products here that help. There's also AWS CloudWatch has a logging service that you can use to search logs. Use that data for troubleshooting and remediation. Again, as we increase the velocity of change in our application, we have to utilize tools. We have to leverage tools in order to monitor and handle those changes, right? So, it's great that we're deploying more often. There's a lot less surface area. So one real benefit of continuous deployment is if you're deploying once every 3 months, that change set that went out from, let's say you have revision A to revision B, is 3 months worth of code changes. If you're deploying 10 times a day, each one of those are probably tiny changes, right? And it becomes very easy to debug what's going on. If some business metric goes south or CPU goes through the roof, it's pretty easy to narrow down exactly what occurred. And having those metrics that say, okay, a deploy happened at noon, and then at 12:02, we stopped getting any new signups. You can very easily correlate and resolve that issue. So other benefits of DevOps, so rapid delivery, reliability, speed. Using DevOps is just a fancy term for using these tools to be able to deploy software to your customers more quickly and monitor your environment and observe your environment so that you can resolve issues more quickly. So let's talk about why this is something we talk about at Amazon and how, what was Amazon's journey through this. So in 2001, Amazon.com, the retail site, was one application. It was one big application. Amazon itself was a pretty big company at this point. A public company. Thousands of people had been working on the code base at that point. And it was they were all kind of playing in the same sandbox. And they found it hard to move, right? It became very difficult to get changes out. Changes would break things, and they wouldn't know about it. It would be hard to add new features to the code base because they'd have to coordinate with all the other teams making changes to the same code base. In the next, within that decade, Amazon.com spent time implementing this two-pizza team concept and taking this large monolithic application and decomposing it into individual microservices. AWS is part of that effort. One of the observations that Amazon.com made is that we have these generic services now that we use internally to build that other people might find useful to build their own applications. And that's kind of where AWS came from. So that 10-year period was, this is an 8-year period, but that decade was a period of decomposing this monolithic application into lots of little applications and moving to this model of empowering small teams of people to completely own a service or a group of services and deliver, be responsible for them from their development through their operational stability. So this was good, right? So now we have lots of services. Amazon was able to scale their development efforts. We were able to more quickly iterate on Amazon.com, the retail site. AWS was born. All of it was good. In 2009, internally, they ran a study. They were trying to figure out, okay, well, we've moved to this model, but how else can we improve? Where else do we have the ability to wring out waste from this process? And what was found through talking to developers and monitoring teams and sort of looking through the data is that there was lots of weights built into the process. So a developer would write some code, and he or she would have to wait for some build process to happen locally on their workstation, and then they would have to wait to be able to deploy it to some environment, and then they'd have to wait again for it to deploy to production. And a lot of these wait steps were coordinating with other teams, coordinating with a release team to be able to deploy, or coordinating with an internal release person, waiting for build resources, waiting for the test environment to free up. So there was just lots of periods of wait built into these spurts of productivity. And so, so this is hard to read, but so some of this was like maybe the task was minutes, but maybe this wait period was hours or days, and all the way through. So the goal was, and as a whole, what could turn into maybe hours of work turned into weeks of work, right? So obviously breaking down the single monolith into a bunch of small microservices, not a panacea, right? There's still a lot of waste in this process. So the goal was, let's eliminate these wait steps and make it as self-service as possible so that changes can get to production and get in front of users in hours, not weeks. So Amazon.com spent a lot of time building internal tooling to support this for automating the software development lifecycle process from the the construction of code, the actual source stage, all the way through production. So I think this is from 2015. So in 2015, there were 50 million deploys at Amazon across everything. So AWS and the retail site and all the different constituencies of Amazon. So that's, well, okay. That's 137,000 deployments per day, about 6,000 per hour, 95 per minute. So this tooling and infrastructure is able to support a very high velocity of changes going out to production all the time across many, many, many different kinds of services. So that all sounds well and good, but like, where do you start? If you are a startup and you have 10 people working on a single product, like, what do you do? Like, how is this helpful or actionable? I would say, I just want to reiterate that, the thing I don't want you to take away from this presentation is that, oh, I have to take my monolith and turn it into a bunch of microservices. That is not the high order bit here. That's, in fact, that is a detail. The high order bit is about enabling your development team with ownership, with the tooling and automation, right? And that's really what we're talking about. Microservices is a detail. If you think about Amazon in 2001, they waited until it really hurt to go down the road of deploying to microservices, and they were a multi-billion-dollar market cap company at that point. So I don't want you to suggest that, like, oh, in order to be agile, in order to do DevOps, we have to have microservices. There are, in fact, reasons not. Like, maybe there's a reason why your monolith is better than microservices, right? Like, it's just easier to reason about. There's less operational overhead. Like, in some ways, small teams can ship on a monolith for quite a long period of time before worrying about any of that. But the high order bit here is communication, ownership, and automation. Okay, does that make sense? Okay, cool. Question mark. So all of these tools we built internally have now an external manifestation in AWS. We've taken those tools that we use every day to ship AWS and the retail site and made it available to customers for them to use it in their own environments. And we're going to talk about all of these. So AWS Code Commit, a lot of them are named code something. We internally call them our code services. They're meant to represent the entire pipeline from source control to production. So Code Commit is our Git compatible source code repository. CodeBuild is our Docker-based build server. CodeDeploy is a deployment coordination system, which will take code and deploy it. And Code Pipeline is a continuous delivery and deployment service that will monitor a source repository for code changes, take some action, build that code, and deploy it somewhere. We're going to go through this a bit more. And in the demo, we'll see a lot of these services in action. Okay, so when you think about the software release steps, there are certain kinds, there are different stages that are pretty common across different kinds of projects, right? So there's a source stage. Your developers are, you're working together on your team, and you're integrating into a single source control system, right? So a lot of teams use GitHub, some teams use GitLab. A lot more teams are using AWS Code Commit lately, just because it integrates with other AWS services. But you're using something, right? You're using some kind of source control system. AWS Code Commit is our source code repository, but there are lots of others here, and those also, other systems also integrate with our developer tools. Build. So now that you've built your code and you've integrated it, now you need something to test that code, right? Or to build that code into an artifact. CodeBuild is a build service that allows you to run Basically, it runs a Docker container, and it'll take your code, and it'll execute whatever commands you specify. So if you have a Java application, it will build that Java application, using Maven or whatever it might be. If you have a Ruby on Rails application, you don't need to build that, right? That's a dynamic, Ruby's a dynamic programming language. But maybe you want something to run your tests, like your RSpec suite or whatever it is. CodeBuild can do that as well. What CodeBuild can do is build that artifact for continuous delivery so that you can deploy your code, and it can also run your tests. Your tests are probably third-party tools. Maybe you're using, maybe you're running a Node.js application and you're writing Mocha tests on the unit side. Maybe you have some acceptance tests in some sort of web browser automation piece of software like Selenium or something like that. You have some sort of test step. So after your code is built, you're running tests against that. And then your deploy step. So AWS CodeDeploy is one way to get that artifact into production. There are some other AWS services that are helpful here, like Elastic Beanstalk, the EC2 container, the Elastic Container Service. There's AWS Ops works as well. So there's a bunch of different services. CodeDeploy is one service to help you take an artifact and put it onto a group of EC2 instances. Does that all make sense, where these services fit and the stages? And any questions? OK. Cool. And CodeDeploy also works. So it works with EC2, but it also works with Lambda. So if you have a Lambda application, you can use CodeDeploy to get that code onto Lambda. And it also works if you have a data center somewhere. You can use CodeDeploy to get code to your on-prem servers as well. Now, Code Pipeline is our service to orchestrate your development pipeline, your deployment pipeline. So what Code Pipeline is a manifestation of these steps in an automated pipeline. So Code Pipeline will monitor your source code repository, will trigger your build system, whether it's like Jenkins or CodeBuild or whatever you're using, run your tests, and then if all that looks good, deploy it to production automatically on every check-in. Yeah. OK, so that's a bunch of services and a bunch of, there's a bunch of words there. How does this effectively work? How do you get started quickly? We launched a service at our Chicago Summit last year called AWS CodeStar. So CodeStar is a service that enables you to very quickly get started in an environment where all these tools are pre-configured for you. There's a corollary service internally. So every time a new service or a new project starts at Amazon, teams will go to this tool. It's called Octane. They'll fill in their project name, and they'll get a bug tracking system. They'll get a deployment pipeline. They'll get a source code repository. Everything they need to successfully ship that product will be automatically built for them. And that's what CodeStar does for our customers. So it will build a source code repository for you. It'll build a deployment pipeline. It'll deploy a sample application that you can build from to things like Elastic Beanstalk or Lambda. So it lets you get easily started. It also integrates with Jira. And there's actually complete integration so that you can have your Jira tickets integrated in with CodeStar directly. And it also has a little wiki that you can use to coordinate with your team. So it's kind of like a dashboard for all of the services you need to develop and deploy a project in one place. And it provisions all the infrastructure you need to get going quickly. Another service we introduced recently at reInvent this year is called AWS Cloud9. Has anyone used Cloud9? Is this new? OK, yeah, cool. So Cloud9 is it's an integrated development environment. It's an IDE. The cool bit is it's basically a web application that runs in your VPC. So instead of coding on your local laptop, getting all the software installed, dealing with that, you can use Cloud9 and start coding right from the get-go. We're going to look at that in the demo. One of the cool bits about Cloud9 is when you start a new Cloud9 instance, you get a panel at the top, which is your code, and at the bottom you get a terminal. Either running Bash, so that you run the AWS CLI right from there. There's a Java, like if you're using a JavaScript language, a JavaScript application, there's a JavaScript REPL right in Cloud9 that you can use to evaluate code. So pretty neat. So the idea here is instead of managing your own IDE, it's there in the cloud for you. You can do pair programming with Cloud9, which is really cool. You can invite other people to view your Cloud9 environment and work collaboratively together. Pretty neat stuff. We'll look at it in more detail in the demo, which is coming up. OK. Any questions before I dive into this and show you a little bit of how it works? Yes, sir. Is Cloud9 used internally at Amazon? I'm sure some teams. Yeah, I'm sure some teams. But Cloud9 is pretty new. So there's an internal cloud desktop thing, which is kind of separate. I'm sure in the fullness of time, you'll see Cloud9 sweep through AWS and Amazon as well. The question was, do Amazon engineers use Cloud9? Yeah. And we have an interest list called Cloud9 interest internally. And it's a lot of Amazon engineers being like, hey, how do I do this thing that I used to do in Cloud9? So a lot of people want to move to it because it's just completely disconnected. They don't have to, people can bring in a Chromebook and use that to work. Cloud9 is an AWS service. It's an AWS service, yep. And we're going to take a look at it right now. It was through an acquisition. It was acquired by another company, but yeah. But it was relaunched as AWS Cloud9. Yes, sir?
I'm trying to wrap my head around the difference and the advantage of using CodeStar with Elastic Beanstalk. If you're already using Elastic Beanstalk, would there be an advantage to utilizing CodeStar in addition to that?
Well, if you already have your deployment pipeline set up and you're already using kind of CodeBuild and that's already configured, there may not be a lot of reason to go into CodeStar, right? Because the whole idea of CodeStar is it kind of bootstraps you and gets you going. If you've already done that work, it might not be very worthwhile. There are some nice things with the Jira integration and the fact that you can manage your team from CodeStar and have their SSH keys added to servers automatically. But if those benefits aren't, it might not be worthwhile if you've already done the work. The question was, should I use CodeStar if I've already deployed my application? All right, so let's take a look at how some of this works. So we have a canned demo here. So this is AWS CodeStar. So when you land on CodeStar, you see a single button, Start a Project. So that's what you're doing here. You're starting a new project from scratch. And there's a lot of pre-built templates with the different environments and runtimes that our customers are using. So things like Ruby on Rails, Java, Node.js, Express, Django with Python, .NET, et cetera. So there's a lot of pre-built templates that are things like web applications. And then there's a deployment target. So for example, this is a Ruby on Rails template that's a web application that will deploy to AWS Elastic Beanstalk, which is our web application platform. Or you can use Ruby on Rails to deploy directly to EC2 without Beanstalk and use CodeDeploy to deploy the code. Likewise, with Node.js, you have the option to deploy the sample code to Lambda or to EC2 or AWS Elastic Beanstalk. Okay? Yeah, so if you look at the sidebar, you'll see all the languages. There's a bunch. There's PHP, Python, Ruby, et cetera. So here, we're going to filter down. We're going to say, I want to look at all the Node.js templates, of which there are 8. And we're going to select one. We're going to deploy Node.js to AWS Lambda. So we're going to build a serverless application, and we want to continuously deploy that. So here, we get a screen where we could fill out our project details. You'll see AWS Code Commit's obviously supported as a first-class citizen here, but GitHub is as well, right? So you can connect your existing GitHub repository to the project, or you can use a GitHub repository there. We'll create a new one. And we put in our project name. We select GitHub. OK. So, and then that's it. So now it reviews our project details. We have our source and code commit here. So we selected code commit. It's going to use CodeBuild for our build and test phases. We're going to deploy using AWS CloudFormation. So we're going to use CloudFormation to drive our deployment process of our Lambda function. And that's all going to be managed for us under the covers. CodeStar is going to configure all of that for us. And then we're going to use CloudWatch to monitor. So these stages from source all the way to production monitoring, all of this is going to be provisioned for you. OK. Next, it's going to tell you how you want to edit your code. So do you use Visual Studio or Eclipse or command line tools or Cloud9? And you can use any number of these. So for example, here we're going to configure our command line tools. We're going to get an example here of how to configure Git for Windows. We're going to, OK, here's more. We're going to copy our repository. A little hard to read, but here's a Windows prompt. We're going to clone our new repository from code commit. It's going to clone it into a directory. And now we have our project on our local laptop ready to go. We can go back here and say, OK, we're also going to set up Cloud9. So Cloud9 allows you, you spin up an EC2 instance, essentially, with the Cloud9 software. So here we're going to run it on a T2 Micro, which is free tier eligible. And we're going to start using that. So CodeStar will start provisioning your environment. So here, project successfully created. And then it's going to spin up a new IDE for us, a new Cloud9 environment. Okay, and then as the provisioning continues, things start popping in. So here, for example, here's our application endpoint. So our application has been deployed through the pipeline, and we can actually click there and see the template. Here's the template. So this is what we get by default. We get some sample code deployed to production with a pipeline to take our changes as we build on top of it. Okay. So let's look at the dashboard a little bit. So here's our template. Here's our CodeStar dashboard. So we can edit, we can remove modules if we don't want to use them. So this is our team wiki. Maybe we have some shared information that we want to share amongst our entire team. We can edit this using Markdown, so we can put in whatever we want there. So we just have a little wiki module to be able to share important information about the project. And down below, so some more important things. So here's our continuous deployment pipeline. So it configured an AWS code pipeline for us. And here are the 3 stages. Our source stage, so it's monitoring code commit for changes. It's using CodeBuild to build our application, and then it's using CloudFormation to deploy it. Likewise, we have right here our CloudWatch metrics. So here we see errors and request count invocations from our Lambda function. So here we can, in the same dashboard where we have our team wiki and our deployment pipeline, we can also monitor the health of our application directly from the CodeStar project page. Okay, so we're going to do an update to our app. So we're going to build on our application. So here, there's our template again. We clicked on the application endpoint here, and here's our template. We're going to go back to our command line prompt here, and we're going to do an ls. So here's what we have in there. We have an index.js file, which is just going to be some JavaScript, a README, and build spec, which is our code build configuration. So let's look at the index. So all that this is doing is taking the contents of the index.html and basically returning it to the caller. So this is what CodeStar provides as a template. So you get basically a little HTML file. It reads that synchronously into memory, and then it returns a 200 with the contents of that page. And that page is going to be this guy, so this HTML page. Okay? So let's open our IDE. So let's go into Cloud9 and change that. So we're going to, in CodeStar right here, so if you look on the sidebar here, there's our dashboard, which is our project dashboard, our IDE, our code pipeline. So all of our resources are right there. So we're going to go into Cloud9, and we're going to, so this is Cloud9. So notice these are all of the files in our project. This is our workspace. This is just a landing page. And here's our terminal. So this is a bash prompt that we can use to run commands to manage our environment. So here's the code again. So it's grabbing those HTML contents, throwing them back over the wire with a 200. Let's get rid of that. So we're going to comment out the contents line, and we're going to replace it with hello world. So instead of reading that file, we're just going to return hello world, just to see a change happen. Okay, we're going to, so now look down below. So here's our console. We're going to configure our Git client. It's a little hard to see. Sorry about that. We're going to configure our Git client, and we're going to basically git add, git commit with a commit message saying pushing change for demo, and then we're going to git push. So now we've pushed those contents up, so now that change is now in our source code repository. Because that change is in our source code repository, our continuous deployment pipeline kicks into life. So the continuous deployment pipeline monitors that. I don't know if you can see this, but this is now blue. That means it's in progress. It's going to grab the latest version of source. It's going to build it. So it's going to use CodeBuild to build a package. And then it's going to deploy. So it's going to use CloudFormation to deploy our Lambda function. So that's green. So our change made it all the way through the pipeline. And then if we go to our application endpoint, we see hello world. Right? So conceivably now we can continue, we can actually build on this template, make changes, build the application, and do something more useful than now put hello world. Okay, so that's kind of the AWS Code Services in a nutshell. So CodeStar manages building this entire environment for you based upon predefined templates. Code Pipeline will manage a continuous deployment pipeline for your project to get your changes to customers as quickly as possible. Code Commit's our source code repository. CodeBuild is a build service. And CodeDeploy is a deployment tool to help you get changes onto EC2 instances. There's a ton of resources here. I would recommend this workshop. So there's a workshop, AWS DevOps workshop. There's also, you'll get a copy of these slides, so don't worry about that. In our GitHub repository, there's an AWS-samples GitHub organization. There's a AWS developer workshop, which goes through what I just did, but with more meat and more detail. And you can do that, at your leisure, at home, and really get a sense for how these tools work and how you can integrate them into your environment. And I think we're out of time, so we have a couple minutes for some questions if anyone has anything. Yes, sir. What is the coolest? Well, so we just have millions of active customers. So me on the startup team, I probably talk to 50 to 70 customers a month. So it's tough. I would say, well, one thing that stands out is something I've not worked on, but MLB. So if you think about, I don't know if I'm a baseball fan, so I noticed the change as a consumer of this product. In the, I think it was the 2015 World Series, there was that head-first slide that Eric Hosmer did, right? And before, you would just argue with your friends at a bar, like, I think he would have made it if he ran through. No, if he's diving, he was dead, a dead duck no matter what. With StatCast, you don't have to have those conversations in theory. You could look at, they basically, MLB, put radar in all 30 major league stadiums, and they're measuring the ball and the players like many, many times a second, and putting that data into AWS using things like Lambda to get results to the broadcast booth within seconds. So within seconds, you have a spark line of Eric Hosmer running on the base path and where he was actually, how proving like mathematically that if he just stayed on his feet, he would have ran through first base and the inning would have not been over. So for me, like as a sports fan, that one's awesome. We have folks working with the NFL on really cool stuff. I don't know how much of that's public, but things like implementing, basically it's so easy to collect data and store data and cheap to do that now. Like the really cool stuff is happening in the analysis of that data. How do you turn those data into something real and something insightful and something interesting? So I don't know if that answers your question, but those are two examples. Yes, sir?
This was just an example of very like a static flow run.
Yeah.
Just out of curiosity, say if I wanted to deploy like something like some like logs of images, or if I wanted to deploy something like continuous streaming, or like just something that's maybe like not just like static content. So if I wanted to do that dynamic.
Totally. Yeah, so this is ready to go for those use cases. So for example, this toy example, we're just doing hello world, but this could be doing any code you want to write, right? So you could be, there are customers of ours are building entire backend APIs and websites on AWS Lambda with little functions like this that integrate their own business logic against their own data storage systems. So CodeStar is built from day one to help you with those use cases. Yes, sir?
CodeStar, then what we saw.
Yeah. Yeah, the question was, does CodeStar support more structured environments where you have different, maybe you go to a staging environment? Yeah, totally. So that's just the beginnings of your environment. That's day one, right? The next day, maybe you have a staging environment. You can easily add that into your code pipeline. Yeah, and basically say, look, I want it to go to staging, and then maybe I want a manual approval step. Maybe we're not ready for continuous deployment, but we want a continuous delivery to staging. And then when we're ready to deploy, hit the button in code pipeline to deploy. Yeah, it supports any number. They're very generic tools. The day one kind of template is something you could build on. Cool. Yes, ma'am. I'm sorry, one more time? Yeah. So the question was, will the old code still be available? Yeah, for sure. So code commit's a Git repository, right? So every commit is immutable and stored in our source code repository. So if you do like a git log, you'll see all the changes made in master, and you can roll back to any one of those, right? Or you can restore your code to that code port. So yeah, it's all still available. You could even, like a lot of services support automated rollback, where you can say, oh, I deployed this thing, but it didn't pass our health check, so actually don't do that deployment, right? So like Amazon Elastic Container Service, you can do that, and then it'll page somebody or wake somebody up to go and deal with it. All right, I think we're out of time, but I'll be around. So thank you again for your attention. I really appreciate it. Thank you for coming.
Yeah, thanks, Sean. So next up, we have Alistair, and he'll be talking to us a bit about artificial intelligence. So a couple minutes of transition time, and then we'll get started.